our special agent, will talk about all the changes that have been made between Java 12 and Java 17.
What are we going to talk about tonight? Well, in this first talk, it's all about what happens with Java since Java, well, actually since Java 11, the previous long-term version, long-term support. We're just going to skip over Java 8 to 11 because I guess a lot of you guys are still on Java 8, like, well, I guess we have many customers that still are, so we're just going to briefly go over it, and then we're going to do the real part, Java 12 to 17, so what are the new features. So Java 8, that was of course like the Big Bang Java version, like the biggest one ever at that time, where lambdas and streams got really they got introduced, and they got a lot of traction at that time. Of course, there was also the new date library. Then Java 9 was all about the JVM modularization and Project Jigsaw. There were a few other things in there. Process API was quite cool, where you can actually access the operating system processes from a Java API. And we had private method interfaces. Java 10 was all about the local variable type inference. I guess this was almost where Kotlin was starting to begin to hurt a bit, and they thought, well, we have to do a few things in that direction. Java 11 added type inference for lambda variables. They open sourced the Java flight recorder. There was a new garbage collector, and things went on. Now, Java 12 to 17, we're only going to talk about the language changes because there's like an enormous amount of changes. And let me just start this one. Because going through all of the changes with new garbage collectors, with new APIs, that would take quite a bit more than the 2 hours we have tonight. So what are we going to talk about? The switch expression, the text blocks, records. I'm guessing here, but I would like to hear in the chat. I would say this is everyone's favorite change from Java. The instance of pattern matching. Then we got the sealed classes, and finally we're ending with pattern matching for switch this time. So starting with the switch expression, it was introduced in Java 12, it got a second preview in Java 13, and it became final in 14. This is a very typical behavior that we've seen for most of these new features that are being introduced. Before, of course, we had this like 2, 3, 4 years between Java versions, and after the slight disaster of Jigsaw and delaying, they said, nope, we're going to do every 6 months, we're going to release a version. So that makes it really easy to push something to the community, get feedback, improve on it in the second installment, and then see if everyone's happy, and then make a final release from it. So, switch expressions, what it's all about. Well, we all know our classical switch statement, right? But this is an expression, it will return a value. So it has a new syntax, it has this arrow syntax. There's no longer a fall through, so there's no longer a need for a break. I guess we must all love that, we don't have this falling through anymore, and forgetting to put a break there and getting errors. The value after the arrow is the value of the expression. You can have multiple labels on the left of the arrow. That's actually new to both the switch expression, but also to the switch statement. They must be exhaustive, all the labels, of course. And having this new thing, of course, Java had to come up with a name, and they called this the switch labeled rule. And it looks like this. So it returns a value, so we can use it as a function. And then here we have this operator, and you can have like multiple values. So basically this is what it now looks like. Might look a bit familiar from other languages. quite expressive and quite easy. So no longer you have to say return this, return that, break. So it's really nice and clear and concise, and I think it's a really good addition to the language. But they did more to the switch expression. There's another variant where you have the classical label semicolon. No, what is it? It still eliminates the need for a break. But values are now returned not via the value of the arrow operator, but via a new keyword, yield. They came up with yield. In the first iteration they actually had return, and then they changed it to yield. You can still have multiple labels. They still have to be exhaustive. Break and continue in here are again not allowed. So every time with a switch expression, break and continue are not allowed. And this is called a switched labeled statement group. And which looks like this. Basically the same example we saw as before, just the points there instead of the arrow operator, multiple labels, and returning a value via yield. Now you might wonder, okay, why suddenly we didn't have a switch expression at all, and now suddenly we got two of them. But as I said, this is called a switch labeled statement group. So it comes much more into its zone in this kind of usage, where you have a case, you perform multiple operations, and then in the end you want to return a value via yield. So, and that's all about switch statements. There's a question in the audience here. Could you? Yes.
I'm not sure if you can interrupt for questions or.
Oh, apparently we can.
All right, thanks. My question is there a reason why they've chosen to use yield instead of return?
Yes, there definitely is a good reason for it. But I guess the answer is, do I know the reason? Sorry?
Yeah, but it's Scala.
Yeah, it is true they had it in Scala, but I think they really, actually if you really want to know, you should look at the YEP which comes with Java 14, but on the top of my head I think it was because they thought return isn't that like intuitive. They thought yield was more intuitive compared to a return, as return is already used for returning values from functions. So they thought that this would really give it a more distinction between the classical return, returning from a method, and this is returning a value, because basically you're not leaving, it could give the impression that you're leaving the method if you say return 12, while basically it's just a return value from the function expression.
Yep. All right, thank you.
You're welcome. Moving on to text blocks. Text blocks were released in Java 13. There were quite a few things which people wanted to see differently, so we got a second preview in 14 and it became final in 15. Just wondering from anyone here, is anyone already using text blocks? Oh, I can see one person lifting his hands. Good. Right. So, good, because then there should be some new value in here for everyone. Well, first thing is very good to know. Text blocks, they're just regular Java strings. They just span multiple lines. So, if I have a hello Java 17 equals same to the text block. The thing on the right there, that is a text block. So a text block basically starts with 3 double quotes and a line terminator, and then you're not allowed to put any other text on the same line. The good thing about text blocks next, that you can really organize. Everyone had their embedded SQLs, however bad they are, or some piece of HTML or whatever text, spanning multiple lines, and you had to concatenate it with pluses, and then, oh, you needed double quotes in there, and then you had to escape them. So that was really like horror and really hard to see. Well, the good thing is within text blocks now you can just use normal double quotes, no more escaping necessary. the placement of the final triple double quotes is quite important. If you're placing it on the same line as the text, you will get no line terminator, and if you're placing it on its own line, you will actually get a new line edit. So here's an example of a multi-valued string. I really like this addition to Java. I've used Groovy many years before, and I can remember they already had text blocks in there, so I really like it. If you would run this piece of code here, you would get an output which looks something like this. Now you may wonder, the HTML and the other lines, they're much more indented to the right, but suddenly in the result it doesn't seem to be that way. And actually you have this whole piece of blue text here, which is called something like incidental line spaces. And basically the compiler doesn't really know, what should I do with this text? Did someone put it here on purpose, or should I remove it? So the rule for the compiler now is that it will pick within all of these lines, it will pick the one most to the left, shift it all the way to the left until no more spacing is left. And then you will get the output like you formatted it. Now you might say, but what if I don't really want to do it, because this would be your normal output? Then you can choose to have the final three closing quotes, to have them put completely to the left, and then basically you're overriding the behavior from the compiler, and then the output would actually be indented with the additional spaces at the front here. There's leading spaces, there's trailing spaces, right? They can't do the same trick, because you can't say just move all the way to the left or the right. In the initial version, there was no real solution, because these two lines, if I would leave this /s escape sequence out, the output would look something like this. There's a lot of blanks behind it, they will all get truncated. So the idea that was there initially is that they said, put some kind of sequence here, like $3 and then do a dot replace $3 with no text, and then you could keep the spaces. Not very elegantly. So they came up with this /s escape sequence, and that basically says keep the spaces here. So if I would run it like this, then the output would look more like this. So it keeps this, keeps the trailing spaces. Right, if there are no questions, then we'll move over to, I would believe, everyone's favorite new feature in Java, but maybe I'm mistaken. I think I would really like to hear what you guys think. Records. Records got their preview in Java 14, got minor changes in 15, and went unchanged to 16. And this is a record. This is how you define a record. So very simple, very concise, and basically you now defined a class. It's an immutable class, but you still defined a class, because a record, it's a special kind of class, but it's still a class. And people might recognize, I think it's Scala, it's called a tuple. It's a data class in Kotlin. In the header, it specifies its contents, its instance variables, although variable is a kind of ambiguous name here, because they're basically final variables. Once you do this, it will generate the constructor, the accessor, the equals, the hash code, and the toString method for you. And like I said, records are final, so once the constructor is completed, the values can't change anymore. So, now you might get to the situation. Of course, this is really concise. Everyone can see, instead of having a big class, and even if you can generate all these methods that he will generate under the hood for you, of course the big advantage is instead of having a long piece of code there's hardly any code. So even if you want to, you don't even have to look at the code to see has anything changed, because if you would have a big piece of code, you might have. Still, if you want to create a record, you might want to do some validations, but we just said that the compiler automatically creates the constructor. So they came up with this thing called a compact constructor, which looks like this, and basically you can use it to validate the arguments with which the record is created. Now, there's a few things here. You see there's no variable names of the arguments coming in, because he already knows what's coming in. Is exactly here in the definition. So you can do your validations, and after the validations, what you would normally do, you would say something like, oh, this dot name equals name, to set the instance variables. But the compiler says, hey, listen buddy, I know what you want to do here. I know you want to have these values, so don't worry about it. I'll take care of it for you. So you don't have to do that. Hence the name compact constructors. Well, this is an example of a bit of a bigger record where we do some validations. We're creating a record here. We're printing it out to the console. And then we're creating actually an invalid record with an h-1. Well, the first statement will print this, the toString, so it shows that the compact constructor actually gets called, and the second one will generate this error. So what more is there to know about records? They cannot declare additional instance variables. You have the ones which you declare on the record, and you can't say somewhere in your code private string another instance var, because then the compiler can't really guarantee that it will be final. You cannot extend other classes or records, actually for the same reason, right? Because if I'm extending another class, that class very likely has instance variables which I cannot control the visibility and the finality of. The accessors, they're a bit different normally from the Java Beans conventions. If you have a name, you would have an accessor saying get name and a setter set name. Well, we don't have setters because we're final. But the get name is being replaced by just the name of the variable. So no longer get name, but name. You can extend interfaces, as many as you want. You can have static fields, static initializers, and static methods. You can add your own instance methods. So there's still a lot of normal class behavior in there. And you can have nested classes and nested records. So you can nest records within records and classes within records. Quickly, one more example with a few of the things we're doing here. As you can see, we're saying here implement action listener. And then down here we're implementing the action perform method that comes from action listener. We're defining some static variable that we're actually accessing here and updating. Here we're printing just a toString, which is this auto-generated method. Here we're using the getter of the instance variable, and this is just an instance method that we're calling here. So one special usage of a record is so-called local records, and basically they're quite useful together with streams, because when you do streams and you map and you sort and you filter, then you sometimes want to have these intermediate values stored somewhere. Very often you have to define then these inner classes or classes or stuff like that, but you can just as well define, like here, a record just like this. So it's just one line, and then you said, okay, I want to have this record person here, which should hold a compact constructor record and an age. The constructor records, they get added here. The stream is being passed in. I'm mapping it, the input, the compact constructor record list, to a person. I'm sorting on it, I'm returning the right information. So you don't have to define these additional data structures. And then you can return that info. This is actually a nice feature which has been added. I'm not sure if it was Java 16 or 17. Normally you would say something here like collectors collect to list or something, and they just thought, okay, this is really getting really bad code that everyone writes this code, so they now got a to list, to map, to set, just as a shorthand. Okay, so now we got the records. Where do we want to use them for? Well, like we saw, data transfer objects is the obvious usage. And I guess that's where, in the beginning, it will be used most. But there's also a thing like safer serialization, or better even deserialization. Imagining you're having some JSON data structure, and you got a library like Jackson, which picks up the JSON and converts it to a Java object. Now, before you really didn't have any control how your object was created. Did it call the constructor? Did it call something like new instance on the class? And how were the variables set? Was it calling getters, or was it trying different ways? You really didn't know. So basically it could set values without even calling your setters, meaning that some validation you might have built in there never got called. Now with records this is of course completely different, because there's no setters and there's no default constructor or a no arc constructor. So basically if you want to create a record, you have to call it via the constructor, and hence it will call the constructor you defined, and it will call this compactor constructor if you have validations in there. So this is much type safer deserialization of data into your application. Well, a few more things about records. On a class there's now a new method called isRecord, which tells you am I a record or not. A bit like isEnum also already had this. And if you want to get more information about the records and all of its fields, its methods, there's this class getRecordComponent, because this is the only way to get that information. Any questions about, oh, there is a question about records. Oh, yeah.
Do you know if the libraries like Jackson or JSON are already enabled for records, or do you have to do something extra?
Yes, they actually have been enabled. So you can safely use Jackson now, and it will make deserialized records the way it should do.
Can you also add like annotations at the field level, where you could, for example, previously on a getter or on a field?
To the best of my knowledge, you can, because basically nothing changed there, and the annotations that you had before, they're basically just, they were actually more for Jackson itself and how to process the data than how to create the objects. So yes, that will definitely work. An interesting part to mention here is, of course, even though this is really, really nice code, records and JPA, for instance, never won't work. One of the things from JPA, it requires a zero arc constructor, right? So that will never really work automatically out of the box. If you want to do things there, then you have to probably wrap something yourself, go through the result set, create records. So, but everything after JPA and putting data to the outbound components, I think records can be very useful. I don't know if we still have Lombok. I guess in the next talk someone will say if that's still there. I don't know. So, yeah. Right.
We also have a question from the online audience.
Oh.
So from the online audience, also for the records, are the default arguments that we currently have right now still there? So like public, protected, private. Can you still do those inside records?
Yes.
That's an easy answer.
Having said that, I haven't really tried it, but I guess
No,
yes.
me neither, but that's a good question to have.
Yes, I'm going for yes.
No further questions.
Oh, we'll edit this out if it's all wrong. Thanks. Moving on to instance of. Instance of was the first time Java dipped his toe into the lake of pattern matching. And so what is pattern matching? So pattern matching is a two-stage process. It is a test that we're performing against an object, and it is to extracting from data from that specific object. So basically we have a pattern, and a pattern consists of a predicate, which will perform the test, and a set of variables called pattern variables, into which the values will be extracted. And this extraction will of course only happen if the test is successful. Well, still sounds very vague. So let's click a few times more, and then in the end, that's code. So bear with me for this example. We have a public interface animal. And as we all know, all animals can speak and they have something to tell us. So there's a cat, and a cat implements an animal, and a cat can speak. But a cat can also jump. Cat loves to jump. And then there's birds. And cats love birds, and that's why birds have the ability to fly away when a cat jumps at them. A cat can't fly, so there's a few things they have in common, there's a few things different. Now, in the traditional classical way, if we would get in an animal object into this code, then we would say something like, oh, if there's an instance of a cat, then let's cast animal to a cat. Let's say the animal, let's say meow, and then make it jump. And the same for bird. And that changed a bit with the instance of pattern matching. This is the classical behavior. And in the new way, we're doing it a bit differently. We're saying here, if animal is an instance of cat, might look like the same instance of we had before, but actually this is the predicate that we saw. And if so, then store it in the pattern variable C. Okay, now you might think, oh wow, this looks very much like smart casting in Kotlin, for instance. But it's really different. It is really pattern matching, and later when we get to the switch pattern matching, this pattern will actually reoccur as a pattern. So it's a bit different. So it uses this pattern variable, it says it for you, so you don't have to do it. They could see in the beginning that it was a bit thin. It's not really exciting code here, right? We're gaining one line of code, but it's a careful start at pattern matching, and we'll get to some more advanced patterns that have been added later. Any question about this part? If not, then we're moving on to sealed classes. Okay, another hierarchy. We have the superclass there, feline, so all cat-like animals. And tiger, pumas, and ocelots, they're all kind of cats. Great. So classically in Java we could say something like this, a public interface feline, and then you have your tiger, your puma, and your ocelot implement the feline. But who's stopping you from saying, I got a class wolf and it implements feline? It wouldn't be right, but there's nothing stopping you in the language right now, is there? Well, there wasn't until sealed classes came along. And basically, how we're going to change this is that you're telling now public sealed interface feline. It says here interface. We both have sealed classes and sealed interfaces. So I'm saying, oh no, wait a minute. This interface is sealed. Not everyone is just allowed to subclass me. I'm special. And you have to be special too. And you can already see that the compiler says made it's okay that you think you're special, but who are the other special ones? So you have to tell him with the permits clause, okay, tiger, puma and ocelot, they're really special too, so they are allowed to subclass me. In this way you can really have more control over your object hierarchy and your object inheritance. And a bit further on in the next and final section we'll see switch classes, and then we'll see a lot of things coming together from these changes in the Java language, that they're not just independent changes, but they work together for a greater goal. So, sealed classes. In order for this to work, the subclasses, so the ones that are in the permitted clause, they need to be available to the compiler at compile time. Moreover, these subclasses need to directly extend the sealed class, so no layers in between, which makes sense because then you can change hierarchy again. The subclasses, they must have a modifier of type final, where they say, okay, inheritance stops here, no one can inherit from me, this is where it ends. It can be sealed, basically again saying I'm sealed, I'm special, and have a permits clause saying who's allowed to inherit from me. Or you can just say, I'm fed up, I don't care anymore, non-sealed. Anyone can inherit from me. One more important thing is that the subclasses need to be in the same module, or if we're not using modules yet, packages in the same package as the sealed class. No sub-packages, nothing like that, has to be in the same package. And records are allowed in the permits clause. So basically we can't say we have a public sealed record. We can't say that, but we can say in the permits clause of a sealed class you can actually name records, which is really, really nice. Right. And then with a few things about sealed classes. They can be abstract, but they're just normal classes in that way, right? Just with a limited inheritance strategy, but they can be abstract. There is again a method on the class class where it says am I sealed or not, so the is sealed, and you can also say, okay, who's allowed to subclass me? And there's a link with pattern matching for the exhaustive analysis of patterns. And basically what we're meaning there is just like with enum, but I think we'll get to this in the next section. Normally you would always need a default to make in a switch statement, or you would need default, and here basically the compiler knows, because you defined your object hierarchy, it knows when all labels have been reached and you don't need a default clause anymore. Any questions here about sealed classes?
Well, not so much a question as remark. I can imagine that you would use this where you would otherwise use an enum when an enum doesn't do, and you need more behavior. Because with this permits clause, it looks a bit like an enum. It tells you explicitly what is part of it.
Yes, that would be one of the ways, but it's really defined. It's really more used for having more control over your object hierarchy. So there's a lot of things in common, and just like you said, just like with a switch knows when an enum, when all elements have been reached, so you don't need a default. That is the same here. So it can be, there's some similarities, but the usages here are really completely different. This is really targeted towards your classes.
Then I would maybe end up abusing it. that would struck me. Oh, this is like an enum on steroids.
Yeah, no, I can see the similarities, and there definitely are, but this is not the intent of sealed classes. In fact, they have been carefully areas of rewriting of the JDK where they now started to use some permits clauses on the hierarchy. So it is really slowly gaining traction, and it's really meant for this object
Yeah, I
hierarchy
can imagine
thing.
that you use it where you cannot make a class final, but neither do you want other users to extend it.
Yeah, you want fine-grained control
Yeah.
over your hierarchy. That's right. Yeah.
Okay.
Right. If there's no more questions, I think we're still very good time for just doing the final subject, which is pattern matching for switch. So we already saw a lot of switch things. So pattern matching for switch. So that's support for patterns in the case labels. There's two additional patterns. We'll see the initial pattern from instance of, they'll be there again, and then there's two additional patterns with the cool names a guarded pattern and a parenthesized pattern. And they also added some special support for null values, because normally passing in a null in a case would blow up your system with a null pointer exception. They thought it would be more elegant to solve it in this way. So, and then switch pattern matching goes very good with sealed classes, and then suddenly you see all of these things coming together. So you got sealed classes, and remember, a permit can be a record, so records really fit into this mix, and then you can use pattern matching, and then as all these changes slowly seem to form a bigger whole, a bigger system. So here you got an example, and this is the first regular pattern matching for switch, which looks very much like we saw in the instance of, right? Because it's basically the same. Basically it tells me again from, oh, are you an integer, then you should do this. If you're long, then do this. And remember, this is just different from what we saw before. Before we were acting on the value which was in this object, right? And now we're really acting on the object itself. Then there is the guarded pattern, which is a bit the same like before. We're still casing over the types, but now it is guarded by an extra condition. So after the double ampersand, so the short circuit end, you can add conditions. And in this case it will say, well, I will only apply this case here if it is a string and the length of the string is larger than 10 characters. And if not, it will go on to the next. So that's guarded patterns. And not sure if we're going to hear later about the patterns which are thought for Java 18 and stuff. So there's like the record pattern, there's the array pattern, where you can extract values already based on conditions from values which are in there. One thing to note here is actually the sequence is quite important. If these two would be turned around, actually the first pattern would already match, because you're basically asking, are you a string? Yes, I am. Okay, great. Then you'll do this. So the order is quite important here. That is something the compiler can't fix for you. That's something you have to do yourself. And again, we have this case null. Normally, if you would come here and you want to do something like this, you would have to say, oh, if not null for obj, then do something. And now you can basically say, well, if it's null, then do this. So more concise code. Then there is the parenthesized pattern matching. We won't go too much into it, but basically it's a guarded pattern again, and there's certain rules here, but there's an end, and there's an or. And the problem is in this last part here, because the end will be evaluated before the or, because it has a higher priority, which will lead to the wrong result. Looking at the input here, on running this example, it will still say that the second one, where we're only printing one exclamation mark, will say this is true, which of course isn't true, because it would validate this rule. But the or at the end gets later evaluated, which leads to the problem. So the parenthesized pattern is not very much more than basically parenthesizing this additional operator, which allows you to specify the order of operations. So What more is there to say? Pattern match, like we said before with the enum, this is a bit of the same example. Remember the feline from before? She had like 3 allows, so the tiger, the puma and the ocelot. So basically I'm doing a switch here now, and I only specified these values, and the compiler knows, well, there can't be any more values because you specified them all. They were in the permits clause, so this is nicely like this. You don't need a default anymore, so this really fits nicely together. Right, and within decent time, I think I completed this. Are there any more questions?
Yes, there's one from the audience. It's actually related.
The audience is here.
Yeah, the other audience online. So it's actually related to your last talk as well about sealed classes.
Yes.
And the people at home want to know, is it also possible to mock these kinds of objects?
You mean for mocking for testing?
Yes, exactly.
Sealed classes.
Yes.
Let me just, why wouldn't it be possible? I mean, yeah, well, that's a good question. I guess you can't answer it back to the audience. But yes, basically they're just normal classes. You just specified them in the permit clause, so I can't see no reason why you can't mock them like any other.
Makes sense.
But it's a good question, actually, because, of course, that's quite an important part of it. So, yeah, very intriguing question.
I think it would also, or it may depend on the kind of unit test framework that you would use. If some framework can work with it, with sealed classes, or others can't. We actually don't know, I think. I'm not sure.
I haven't really heard about any problems with any frameworks, because again, you would maybe much more wonder, can all testing frameworks already mock records, for instance? That would be interesting. Although a record is just a kind of a class, but not really, right? So maybe they have to do a bit more work there. But sealed classes are just another class or something. I mean, the class itself is like any other class. It just is limited in, well, actually it's not even limited. It's the main class that is really the one that is limited from whom can inherit from it. So
makes perfect sense.
Are there any more questions? Great. All these examples can be found on the GitHub repository. And well, that gave you a good introduction to Java 17. I think Java 17 really, you know, it's the next LTS version. It will be the LTS version for 3 years. And just at the beginning of this month, at Spring 1, Spring actually announced that the baseline, the minimum baseline for, what was it, Spring Boot 3 and Spring 6 will be Java 17. So basically, if you want to keep up in future with new Java versions, with new Spring versions, then Java 17 would be a good starting point. Having said that, Spring Boot 3 and Spring 6, they're scheduled for fourth quarter of next year. So there's still plenty of time to migrate. And on that subject, I'm going to pass on to Johan. Well, thank you. Anyone?